Hi everyone, I'm just going to show you how to do a horizontal translation, same as the vertical translation. We're just going to follow this rule here. So we've got our chapter 18 extract, and the relevant rule is y is equal to f of x minus k. Now the minus k is in brackets, and the minus is part of the rule that we need to follow. So we're just going to follow along with this. Look at the picture and see, and make sure we can do the algebra that connects to that. So they've got, let's look at the picture first. That's usually the easiest way to go. Y is equal to f of x is this light blue here. This one's a parabola. And as you can see, they've moved it k units, some number of units off to the right-hand side. And you can see they've got the dark blue there is the same shape, but obviously shifted to the right. So we've got y is equal to f of x minus k is this situation on the right-hand side here. Now, an important little note for you is it's moved k units. If we think of k as like +2 or +3 or some positive number, this minus here is still in the rule that works for this. So sometimes it's easier to do the algebra and then you'll see the impact it has, but it's maybe not as intuitive as if, you know, plusing k would shift to the right hand side. We definitely minus k. The other way I think about this is if k is greater than 0 or positive, the graph moves to the right. So that's what's happened here. Even though it says x minus k, the second graph is to the right. If k was less than 0 or a negative value, the graph moves to the left. And just to be really clear about what they're suggesting there is if k is less than 0, we could say f of x minus, which is part of the rule, and we could say like negative k, making k less than 0. The way we would actually write this, because there's two negatives, they cancel out, we would actually write x is equal to, sorry, f, this is all equal to f of x plus k. And what that would do is if you ended up with something in this format with this plus here, x plus some number, it would move it left. So I hope that's all clear for you. We're going to do a quick example so you can have a look at it anyway, but let's just get our whiteboard up. So I do have one ready to go. I've got the same quadratic I used a moment ago. Oh, let's get rid of my annotation here. I don't need this anymore. I don't need that. Get rid of that. Let's just have a quick look at this quadratic. So we've got, oh, turn off all my dots, don't need these labels. Okay, we've still got f of x equal to x squared minus 5x plus 4, which I used in my vertical translation video as well. But we're going to shift it left and right. So let's go and have a look at the algebra. So same rule. We need to move this. Let's start with 3 units to the right. So what we'll do here is I need my whiteboard. And here we go. All right, let's just do this. Okay, so here's our function. F of x is equal to x squared minus 5x plus 4. I'm going to change these to blue. And this is going to help some of us realize what was happening here. So x squared minus 5x plus 4. So, and the function is f of x equal to these things here. And our new one's going to be to translate it horizontally, left and right. Oops. 3 units right. And if we follow our instructions from the textbook, it tells us that y, to do this, the algebra that goes with this is that f is equal to x minus 3. minus goes with the right, plus goes with the left. Okay, so let's replace all the x's that are in blue with x minus 3. I'll do this in red, so it's really clear. So we've got f of x minus 3 is, there's a blue x to start, so we're going to change that to x minus 3. So that's that. The squared is part of the original function. We're going to keep that the same. Minus 5 is part of the original function. That stays the same. And x minus 3 replaces the blue x to start with. And plus 4 is part of the original function. So might carry on from red. Now you can see where the replacements came from. I'll just carry on in red for us. So what we want to do is we still want to end it up with something that says some number of x squareds plus some number of x's plus c. Like if you typed all of this into Desmos or any graphing software, it would work, but it's not really clear. It definitely would go 3 units, right? It's not really clear what the it's not really clear what the quadratic is in like our preferred format. Like we wouldn't be able to factorize this very well. It's not clear to see the x and y intercepts as an example. So we're just going to work on this until we get a line of working out that we like. So what we're going to do is we're going to just expand these brackets. This is binomial expansion. So it's important to remember those first 2 brackets. When it says squared, you need to multiply the x minus 3 by itself. And if it's nice for you to see the crab claw situation, we're going to do x multiplied by x. We're going to do x multiplied by -3 next. We're going to do -3 multiplied by x. We're going to do -3 multiplied by -3, which gives us our nice crab claw shape. The very mathsy term is binomial expansion. Bi meaning 2, expansion meaning multiply. So let's, I'll get rid of those. They're not very neat. But anyway, x times x is x squared. X multiplied by -3 is -3x. I've got another one that's -3x again. So I've actually got -6x here. And -3 times -3 is +9. Right, that's that bracket. Let's do these. Let's expand this out. -5 times x is -5x. -5 multiplied by -3 is +15. That plus looks like a bit of a trident, so I'll fix that. +15, that looks better. And the +4 is still there from the beginning. So just to make it like super clear, this has been expanded out to equal that. That's where that came from. And if I do a bit of pink here, this -5 by this bracket has turned into all of this. And this +4 is this, just it didn't change, but it's still sitting on the end there. Okay, now we can add everything up. We've got x squared, and there's no more x squared terms. I run left to right. I do have -6x here and a -5x. All that adds up to -11x. I've got a +9, a +15, that's up to +24, and a +4, that's up to +28. And this is our quadratic in this format that we like the most. And if we've done everything correctly, it should be 3 units right. Whoops, I left an S off over there, 3 units. So let's go and graph it and have a look. So we'll go back to horizontal translation. As you can see, I have prepared this already because I mucked up my last video. Anyway, here's our original one. Here is y is equal to x squared minus 11x plus 24, which is what I just came up with. Now, the way we're going to check this is to look at our turning point of the first one. Pop a label on that. We've got the turning point, the vertex of the blue one, which is our original function, x squared minus 5x plus 4 is equal to 2.5 and negative 2.25. If you prefer to think in fractions, they're written there, but they're labeled there for you as well. Now, if this has gone 3 units to the right, it'll be the same value of y's. So like it should line up with the same y-axis. But it should be 3 units bigger on the x-axis. So if I do this, 2.5 gets plus 3 gets me to 5.5. 5.5 as a fraction is 11/2. That's how that got there. And as you can see, this did go exactly 3 units to the right. You can see it's the same shape. It's the only thing that we changed. So that has successfully moved 3 units to the right. I'll quickly do. So your function is this one. Oops, I didn't want to do that. I did want to do that. That's better. Your function is this one here. And this one here, 3 units, the original one, 3 units to the right. Okay, let's go and have a quick look at just one to the left, just for really making sure we've got this down pat. So if I did 3 to the, let's do 4 to the left. So what I'll do is I'll just get rid of all this. I don't want any of this anymore. I'm going to quickly do 4 units to the right. And oops, okay, that's all gone. Let's go 4 units, sorry, to the left is what I want. And what we're going to have to do here is go horizontally 4 units left. So we do this is instead of -4, we add 4. We're going to add 4. I'm just going to do the whole thing in red this time, so I don't have to change colors. So here we go. Let's go. Replace the blue x squared. X plus 4 squared minus 5. Whoops. 5. X plus 4 again. I'll spare you the extra algebra. I'll just expand this really quickly. X squared plus 8x plus 16. If you're not sure how to do that, check the start of the video. What's one? Minus 5x minus 20. That's this bracket expanded plus 4. And we'll go, oh, I don't like this look of that squared. I'm just going, it's a bit low. Let's put it back where it belongs. Pop it, yeah, just up there. That's better. Okay, x squared, x, 8x, minus 5x is plus 3x's. 16 minus 20 plus 4. Oh, that's 0. 16 plus 20 is positive 4. Oh, no, it's, sorry, plus 8. I made a mistake. Okay, here we go. So here is the original quadratic moved 4 units to the left. And if you don't trust me, you can go and graph that one in Desmos yourself and compare it to that one, and it should be 3 units. Sorry, 4 units to the left. Oh, do you know, I don't trust my algebra. I'm actually going to go and have a look. Let's just quickly look. Right, x squared plus 3x plus 8. Let's go and have a look. Desmos. Get rid of this. Get rid of this. Get rid of this. Oops. Okay, here we go. Let's do this. X squared plus 3x. What was it? It was, oh, plus 8, that's right. Plus 8. Oh, I have been mistaken. Nothing there. Oh dear. Right, some live fixing here, everybody. What's happening here? Well, that's minus 4. Oh, it is 0. It is 0. Got it right the first time. Oh, that's wrong. All right, let's get rid of that. Okay. X squared plus 3x. Let's check that. 16, take 20, negative 4 plus 4. Yeah, it is 0. All right, great. Let's go back to Desmos and get rid of plus h. There we go. That's better. Okay, 4 units to the left. We can see the turning point right there. Make it red because our graph here was red. And there it is in all its glory. 4 units to the left. There you go, translating horizontally on the x-axis.